Hi, this is Paul Huller, founder of Brightwave Energy. Welcome to our video training library. Today we're going to talk about the comparison between natural gas prices and electricity prices. Now I'm going to warn you that there are a few things I'm going to talk about when we talk pricing that are fairly controversial, and not everyone's going to agree with these. But the three areas that I really want to talk today are: how do you convert dollars per MCF of gas into dollars per kilowatt hour of electricity? Secondly, I'd like to talk about what drives the prices of both natural gas and electricity. And then finally, I'd like to wrap up with talking about how do you decide which to use in different applications. I know this sounds a little confusing, but here's a simple question. Let's say that you're working for a client in a resort who wants to install a new jacuzzi and a swimming pool. They want it heated all the time for their guests. You need to decide if it's more effective for them to use electricity or natural gas for heating the pool and the jacuzzi. All right, let's take a look. This can sometimes be intimidating, so I want to go over the basic terms that are used in the industry. Okay, natural gas is usually measured in cubic feet, or MCF, which is 1,000 cubic feet. Now, that changes a little bit, but that's usually measured at 1 atmosphere and at 60 degrees Fahrenheit. However, it can also be measured in BTUs, which are British thermal units, MMBTUs, which are 1 million BTUs, or therms or decatherms, where a therm is 100,000 BTUs and a decatherm is 10 therms. Electricity is probably a bit simpler and usually measured in watts, where a watt is equal to 1 joule per second, but in electrical terms, it's the power dissipated by 1 amp flowing across the potential of 1 volt. Now, a watt's not very much, so we usually use something called a kilowatt, which is 1,000 watts. Sometimes for larger applications, we use something called a megawatt. An easy conversion factor between natural gas and electricity is to know that 1 cubic foot of natural gas has the same energy as 0.292 kilowatt hours. So 1 kilowatt hour is equal to 3,412 BTUs. So let's do a quick conversion. Let's say that you want to install a heater in a manufacturing plant. The heater will require 100,000 MMBTUs. Your electrical rate is 6 cents a kilowatt hour, and you're paying $5.50 an MMBTU for natural gas. Well, we know that 1 kilowatt hour is 3,412 BTUs, so 1 kilowatt hour is 0.003412 MMBTUs. Therefore, your cost would be, go through the math, and you'll see that your gas cost would be $550,000, but your electricity cost would be $1,758,000. Now, if you're not sure how we are actually doing these calculations, go back and watch our second video titled Performing Dimensional Analysis. Remember, keep it simple and you'll get the right answer every time. So we've calculated that our gas will cost $550,000, or if we did it with electricity, it would be about $1.8 million. So which would you recommend for the plant? Furthermore, if the plant already had an electrical heater, would it be worth replacing it at this point with a natural gas heater? Now let's move to the key things that drive natural gas and electricity prices. This is the controversial part. In my opinion, the three areas in order are: first, supply and demand. This is straightforward economics, and we see this especially in petroleum supplies. Now with electricity, we often see the cost change in tiered markets for different times of the day due to the higher demand. Secondly, I call it politics, policies, and laws. I actually place this second area as more important than inflation. Laws, regulations, mandates, carbon taxes, and rebates all have a tremendous impact on the market. These legislations artificially drive the cost of energy higher, as utility companies are forced to produce energy in compliance with the barrage of new laws that are always being passed. This is the primary reason why residents of California pay 14 cents per kilowatt hour for the very same electrons of electricity that Texas residents get for only 5 cents per kilowatt hour. That's almost 3 times the price for the same power, and that's driven by laws, policies, and politics. The third area is inflation. This runs between 3 to 6% per year for electricity, but actually it has almost no effect on natural gas, which is so driven by price that it really outshows the other two. Finally, let's discuss briefly how to decide when you should use natural gas versus electricity for any given project. First is availability. It may seem simple, but if the energy is not available, it's not available. I've done some work on an island in the Caribbean. They don't have natural gas there, so their only choice is electricity, no matter what the cost of that electricity is. Secondly, you have to evaluate stability. So some areas of the country have notoriously bad reliability with their electrical grid. Whether that's due to bad weather or unreliable equipment, the bottom line is the loss of electrical power, even for a few minutes, can have a devastating effect on some operations. Third is cost. This is very important, but it should not be the only consideration. And then finally, number 4 is flexibility. Flexibility is often the name of the game, because a system that allows for either natural gas or electricity could be an invaluable feature for your client in the years ahead. I hope that this comparison between natural gas and electricity has been useful for you as you evaluate these two fuels in your work. This is Paul Huller of Brightwave Energy. Thank you for visiting our video training library.